mole concept. So if you remember, we can go from mass in grams or between. Let me show arrows two ways. There's an arrow that way and there's an arrow that way. I can go from mass in grams to moles, whatever it is. And I can go from moles to number of particles, or from number of particles for that matter. All right. And so if I'm going from, well, let's see, if I'm going from moles, well, let's go this way. If I'm going from grams to moles, I'm going to divide by molar mass. If I'm going from moles to grams, see the arrow's going that way on the top, then I'm going to multiply by molar mass. If I'm going to go from moles to particles, I'm going to multiply by Avogadro's number. If I'm going to go from number of particles to moles, I'm going to divide by Avogadro's number. And so we can do some simple things. We can do this, by the way, a particle can equal either an atom, if it's an element that's not diatomic, such as aluminum, or it can equal a molecule if it's a diatomic element, such as hydrogen, or it can also equal a molecule if it is covalent. I'm just being specific here, such as water or carbon dioxide. Technically, what we call a particle, if it's an ionic compound, we refer to it as a formula unit. It's just semantics, or just giving it a different name, which is 1 unit of an ionic compound. Because you never get, like sodium chloride is an ionic compound, but you never see one individual sodium chloride. They come as a lattice. So, but we can, the idea of one single sodium ion with one single chloride would be called a formula unit. Or if we had calcium chloride, which would be one calcium ion with 2 chloride ions, that would be a formula unit, right? So we can think of the idea of that, and we can have a bulk number of them, right? So that we can have millions of them or billions of them or whatever we need. Okay, so this idea is really key right here. This is just definitional. We can do some examples. So if I have 43.7 grams of, let's say, methane, and I figure out how many moles that is. You guys remember how to do that? Oh, look, lots of people are joining. Good. All right, so how would I do that? So I'd look at my pathway sheet and I'd say, okay, where am I starting? I'm starting with grams. So I'm here and I want to go to moles. So that, what would I multiply or divide? What does it tell me to do? Anybody? Which arrow am I taking? Nobody? Okay, it says divide, right? The bottom, the arrow that's going from here to there says divide. So that's what I would do. So we could also, do you guys want to review how to do molar mass? Maybe we could do that too. So 1 mole of CH4, I have to find what it's equal to. So I find that molar mass from the periodic table, right? Let me back up from that problem. Let's do a different one first. Let's actually, instead of starting with a molecule, let's start with an atom. What if I have, let's use the same number, 43.7 grams of aluminum, and I want to find moles. So let's do the same thing. So I'd look on the periodic table, and I would find aluminum here. I don't know if you guys can see it very well. And probably my focus is 26.98. On the periodic table, that means 1 mole of aluminum atoms equals 26.98 grams. Periodic table. All right. So, and I'm looking at I've been given grams. I want to go to moles. So I'm going to have to divide by molar mass. All right. So I'm going to take my 43.7 grams of aluminum. And so to divide by the molar mass means I'm going to have multiply by 1 mole of aluminum over 26.98 grams of aluminum, right? And so how many sig figs is this measurement here? Can you guys see that? So people were saying yes. I guess they're seeing stuff. So, okay, someone said 3. What about this? Does this have sig figs? Oh, actually it does. This is someone had to measure the mass of aluminum. It's actually not infinite. There is something else we'll see. We'll see infinity in a little while, but not here. So when I look at aluminum on this periodic table, it's 26.98. But if I looked at aluminum on another table, it might have 5 or 6 sig figs. So let's put those in. See, this is why I'm gonna do the review, because this is important. There's 3 sig figs here. This is 4. This 1 here comes about by division. So it's really not. So I have 3 divided by 4. I could show this with my calculator. Let's see if I can. So I'm going to try to show it where it doesn't glare. 43 point, oh, I got to turn it on first. Oh my goodness. Okay. 43.7 divided by 26.98. Oh, good. I have scientific notation. Times 10 to the 0. So, aha. Well, what would I see? That looks like 1.6197. But how many sig figs do I want? Looks like 3. So what would I end up with? Anybody? I got a round. There we go. Someone said 1.62. I need to round up. And then my unit, you guys should really do this. You should cancel the units that I have. Grams of aluminum over grams of aluminum cancels, giving me moles of aluminum. So that's my final answer. Okay. Let's use this answer. Let's say if I have, well, should we do, so that's an element. Let's actually find, how about 43.7 grams of methane, and to find moles of this. So in order to do this, I have to kind of look at the periodic table, right? So in one CH4, molecule equals how many carbon atoms in one molecule? Anybody? And how many hydrogen atoms? Nobody's answering. So in one molecule, I have one carbon atom and 4 hydrogen atoms. Does that make sense? I hope that makes sense. Okay. So let's continue from there. What if I had 100 CH4s? How many carbons would I have following the same pattern? Anybody? Yes, 100 carbons. And how many hydrogens would I have? Well, I'd have to multiply by 100. Yeah, 400. There you go. Perfect. Okay, let's use a bulk number. What if I had 1 dozen CH4s? How many carbons would I have? Well, 12, but I'm going to keep the bulk number. I'd have 1 dozen carbons. Yeah? And how many hydrogens would I have? 48, someone said, which I'm going to call 4 dozen. All right. Now I'm going to use a bulk number. So a dozen is a bulk number, but so is a mole, right? So it's on the side. 1 dozen equals 12. It's just a bulk number. 1 mole equals 6.022 times 10 to the 23. It's just a bigger number, but it's like a dozen. So if I have 1 mole of CH4, how many carbon atoms do I have inside that mole of particles? Nobody? Okay, well, I would say I would have 1 mole of carbon inside, right? Just in the same way, if I had 100 methanes, I'd have 100 carbons, right? It's just a number, right? How many hydrogen atoms would I have? I would have, so no one's answering, 4 moles of hydrogen. Now these, I can find the mass of, right? So 1 mole of carbon from the periodic table is 12.01 grams. 4 moles of hydrogen would be 4 times 1.01 grams, which would be 4.04 grams. So if I added that up, let's move this over, 12.01, I get 16.05 grams of methane is equal to 1 mole of methane, right? And I can do that with any formula on the periodic table. Okay, so let's go back to the original question. So we spent all that time just showing how to get the molar mass. I wanted to prove it to everybody. Okay, so now I have 43.7 grams of CH4. And if I look at my mole subway, I'm at grams and I want to go to moles. So I still want to divide by molar mass, right? So times 1 mole of CH4 over 16.05 grams of CH4, right? And so, oh, let me show that. Okay. And so now grams divided by grams cancel, and I get moles. Also, this is 3 sig figs, and this is still 4. So my answer will have 3. I type that into my calculator. It looks like a little less than 3, right? 16 times 3 would be 48. So let's look in the calculator and try not to get the glare. Okay. So 43.7, whoops, clear out. 43.7 divided by 16.05. And I get 2.72. That sounds like a little less than 3. 2.72 moles of CH4. We could also go the opposite way, right? Let's continue. What if I go from, I start with moles. So what is the mass? I'm going to use the same example. Let's just change the number of moles. What is the mass of 12.3 moles of CH4? And so for this one, using the mole subway, bring that back up. It's a really useful little picture, isn't it? I'm starting with moles and I want to go to grams. So now I want to multiply by molar mass. Good, someone said multiply. Thank you. So I'm going to take 12.3 moles of CH4 times 16.05 grams of CH4 divided by 1 mole of CH4. So moles of CH4 cancel with moles of CH4 and I get grams. That's going to be a big number, 12 times 16 essentially. I'll just spare you the sig figs. 12.3 times 16.05 looks to me to be, well, I get 3 sig figs, 197 grams of CH4. Okay. Okay. Let's do some other stuff. Let's go. What if we want to go from moles to number of particles? How many CH4 molecules are in 12.3 moles of CH4? So if I look at this, I'm still here at moles, but instead of wanting to go this way, I want to go that way, right? So now if I'm going, I'm going from moles to particles, I want to multiply by Avogadro's number. So I'm going to take 12.3 moles of CH4 times 6.022 times 10 to the 23 CH4 molecules over 1 mole of CH4. Put that up. Okay. So I'm going to cancel moles of CH4. And let's do a check here. How many sig figs is my mole measurement? 3. Okay, good. How many sig figs is this? It's okay. So I got infinity 4, 5. So this one's actually 4. So this is actually an approximation, just like pi, right? When we say pi is 3.14, that's a 3 significant figure approximation. We know pi goes on forever. And this is a similar, this one doesn't go on forever, but, well, the one, this one is actually technically a count. So that's not 1 sig fig. I guess you could call that infinity, and this is 4. Okay, so yes, good. All right, at any rate, I have 3 and 4, so I'm gonna end with 3. So, and it looks like, well, 12 times 6 is about 72. 72 times 10 to the 23 would be about 7 something times 10 to the 24. So let's check it. 12.3 times 6.022 second 10 to the 23. Yeah. And so I get, it's 7.0, well, I get 7.407 blah, blah, blah times 10 to the 24. And actually, if I want 3 sig figs, that's going to have to become 7.41 times 10 to the 24. Yeah? Okay. So there we go. We could also go backwards. let's go backwards. Let's use the aluminum, actually. So remember, aluminum is 26.98 from the periodic table. How many moles of aluminum, are in 2.68 times 10 to the 21 aluminum atoms? So for this one, let's look at our mole subway. And so now we're given particles, right? And we want to go to moles. So in this case, we want to divide by Avogadro's number. I'm going to take my 2.68 times 10 to the 21 atoms of aluminum. And so I want to divide now times 1 mole of aluminum, over 6.022 times 10 to the 23, move it over, Al atoms. You need parenthesis when dividing, right? And so we can actually look at this before I even do it and kind of guess what it should be. But so let me put the parenthesis in there, because if I want to phrase it in the calculator with the parenthesis. If I don't do that, it's going to go 2.68 times 10 to the 21 divided by 6.022, and then it'll take the times 10 to the 23 and put it up in the numerator. And I don't want that, so that's why I use the parenthesis. And we can estimate to make sure we got the correct answer. For instance, let's get rid of the coefficients. What's 10 to the 21 divided by 10 to the 23? So 10 to the 21 divided by 10 to the 23 should be about 10 to the minus 2, right? When you divide, and you have a common base, you subtract the exponents. So I'm going to have 10 to the minus 2, but also, you know, this is about 3 and this is about 6. So 3 divided by 6 is about 0.5. So 0.5 equals 5.0 times 10 to the minus 1. So 10 to the minus 1 times 10 to the minus 2, this answer should be around 10 to the minus 3. So it's estimating. You guys can work on that. But at any rate, I'm going to take my 2.68, 10 to the 21. What I like to do is hit enter, and then it puts it in the memory space. And then I divide by parentheses, 6.022, 10 to the 23. Now I have two parentheses. There's the parentheses for the exponent and the parentheses for the whole term. So I need to actually close. If you don't phrase it properly, your calculator will probably give you an error message. But anyway, after doing that, aha, so like I predicted, it's about 5 times 10 to the minus 3. That looks like a really good answer. This is 3 sig figs, this is 4, so I get 4.45 times 10 to the minus 3 moles of aluminum. And you can do that. You can have a really small amount of moles. How many molecules in, well, let's say 7.53 grams of methane? Question mark. Okay, so for this one, I'm going to go from grams to moles, which means divide by molar mass, and then moles to particles, which means multiply by Avogadro's number. I'm going to take 7.53 grams of CH4. I want to divide by molar mass, 16.05 grams of CH4, 1 mole of CH4. So grams cancel, and I have moles. And then I want to multiply by Avogadro's number, 6.022 times 10 to the 24 CH4 molecules over 1 mole of CH4. So now moles cancel. Maybe I'll use a different color for that. right? And then it's just calculation. This is 3 sig figs, that's 4, that's 4. So I should have 3 in my answer. And we could estimate this if you want. It's this is about 8 divided by 16 is about 1/2. 1/2 of 6 is 3. Gosh, it's going to be about 3 times 10 to the 24. Let's find out. 7.53 divided by 16.05 times 6.022, 10 to the 23. And I get, yeah, really close to 3. 2.83 times 10 to the 23 CH4 molecules. Okay, we could also go backwards, right? Let's actually use this same value. If I had 2.83 times 10 to the 23 CH4 molecules, could I find the number of grams? This is kind of a check for yourself too. You could do this on the test, right? So in this case, mole subway, I'm starting with particles. I'm going to divide by Avogadro's number to get moles. And then to go from moles to grams, I'm going to multiply by molar mass. So 2.83 times 10 to the 23 CH4 molecules times 1 mole CH4 divided by 6.022 times 10 to the 23. Put it in parentheses, molecules, right? So molecules cancel with molecules. Then moles, I want on the bottom, 1 mole of CH4, 16.05 grams. So moles cancel with moles. And then you could check this for yourself. You should basically get 7.53 grams. Now this wasn't, I rounded that number, so this might be off by point, maybe it might be 7.54 or 7.52. But basically, yes. Did I do? Oh my gosh, what did I do here? Yeah, that one, huh? Okay, this one's correct. That one is not. What did we do here? This is the answer wrong? Let's see. This is 1/2. This answer is still right. I just did a transcription error. But this answer is the same. Thank you. Sorry about that. I was going to get writing a little fast. Thank you. Avogadro's number is 6.00022 times 10 to the 23.